Welcome to this fifth video in a series of work solutions for GCSE Computer Science, working towards Paper 1 for Edexcel GCSE. If you've made it through all the videos so far, well done, give yourself a pat on the back. We're going to work through how to get to the answer for question 2a, which is about binary and denary conversions, and then your challenge at the end is to read through and attempt question 2b. So let's have a look at question 2a. Some of these questions look complicated, but if you zone in on the most important information, they become a bit simpler. So we've got a sensor that says a drone is 78 meters above ground. My amazing picture of a little drone, there we go, 78 meters above ground, which is a denary number. So denary is what we think of as a normal number. We need to convert it to 8-bit binary. Lots of ways of doing this. I'd recommend that you start by writing out the bit value for 8 bits. So start on the right with a 1 and double that number as you keep going across to the left 8 times. So we're going to do 64 and 128 and stop because we've now got 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Then we need to work out what combination of these numbers we need to add together to get to 78. And if we need to add those numbers together, we put a 1 underneath. For example, 128 is too big. It's bigger than 78, so we don't want 128. We do want and we need 64 to get to 78. If we've got 64, how many more do we need to get to 78? That's the same as asking what's 78 minus 64, so that's 14. If we've got 64, we need 14 more to get to 78. In that case, 32 is too big to get to 14, so that's a 0. 16 is too big to get to 14, so that's a 0. But we're going to need an 8. If we've got 8, then how many more do we need to get to 14? We're going to need 6 more. 8 plus 6 is 14. So now we want to try and make 6. We can make 6 from 4 and 2, but we don't need that 1. So I'd recommend testing after you do this. So let's see, 64 plus 8 plus 4 plus 2, add those together and you get our 78. There's 2 marks available here, 1 mark for the first 4 bits, 1 mark for the second 4 bits, as long as your answer is an 8-bit binary number. So you've got to have that leading 0. You can't just write 1001101. Okay, let's have a look at the next question. So, convert the 8-bit binary number, so this 8-bit binary number to a denary. So it's like the opposite of what we were doing before. I'd still recommend starting by writing out the bit values for 8 bits. So 16, 32, 64, 128. We're just doubling as we move across to the left. And this time I'd write out each bit underneath. So 3 zeros from here, 1, 1. Oh, hang on, sorry. So 3 zeros, then a 1, 0, 1, 1. Then it's like what we had to do to test the last section. So we just add all of the numbers where we have a 1 underneath. So 16 plus 8 plus 2 plus 1, add all those together and we've got 27. Bizarrely, you get 2 marks for this. You get 1 mark for saying 20-something, and 1 mark for the last digit being 7. So if you'd said 26, you'd get 1 mark, or if you said 17, you'd get 1 mark, but 27 would get you both. Okay, finally, this one looks a lot more confusing, but it's not that bad once you understand what it's asking you to do. So let's have a look. Let's just bring up the highlighter. Here we go. Thank you. So it says the drone gets the latest value, so for the altitude, how high above the ground it is, and it gets the previous value, a fraction of a second before, and it does an arithmetic shift, we'll talk about what that means in a mo, to half its value. So if you add 2 numbers and divide by 2, that's the same in maths as taking the mean, the average of those 2 values. So let's say it's that far above the ground, it was that far above the ground, we add the 2 together to get that. The question actually only asks us to do the arithmetic shift on this number to half its value. In order to know what to do, we have to understand what a shift is, we have to know which direction to do the shift to half its value, and we have to know what an arithmetic shift is. So first of all, let's talk about shifting. We know that bits double in value as you move across to the left. So if you have a binary number, let's say 4, and you shift it across to the right, it becomes, so that 1 has moved across here, it's halved in value. If you were to move it across to the left, then it would double in value. Here we want to halve the value, so we're shifting right, in the right direction. So, it's not letting me rub these out, help. There we go. So what we want to do is shift our binary number to the right. So let's start with our original number, 0011, 0111, and we want to shift each bit across to the right. So let's start over here. The 0 comes here to 0, that 0 comes here, that 1 comes here, that 1 comes here, that 0 over here, that 1 over there, that 1 over there, and this one gets lost. We don't write it over here, it just gets lost. We've got a gap over here, and because it's an arithmetic shift, all that means is the most significant bit gets preserved. If that was a 1, this would be a 1 here, but because that's a 0, that stays a 0 over here. So that's slightly different to a logical shift where it's always just a 0 that appears over here. It's worth having a look in your revision guide if you want to get familiar on arithmetic or logical shifts. The important bit here is just shifting it across to the right. 2 marks available here. If you'd shifted to the left by accident, so you ended up with, let's have a look, that would be 0, 1, 1, that 0 goes here, and then 1, 2, 3 ones, and then you'd shift in a 0 across here. If you'd done that by accident, shifting the original value to the left, you'd get 1 mark, but for 2 marks you have to do an arithmetic shift to the right. Okay, that's probably the hardest question so far. If you read through question 2b, all of these involve understanding 2's complement. So read up on 2's complement before you attempt this. The key difference here in 2's complement is one method of doing binary, where the only difference is 16, 32, 64. The most significant bit isn't 128 anymore, it's just minus 128 instead. So if you understand that and read through this question, you should be okay. And we'll talk through how to get to the answers in the next video. Thanks, I hope that's been useful. All the best.